Okay, so this is CUTSIE WHUN drive motors, drive system. Now the gauges that you're seeing down here, those are the tip indicators, and they're running through a packet command into the serial, and you've got different gauges you can use. I use this to center it and clean up the Kalman filter, and it actually did a really good job. I mean, if you look at me tip it, you can see how the needle on the left is jerky. That's the raw feed coming right off of the gyro right here, right after the average point. That is where that first one is. The second one is coming off of the Kalman filter here. It's taking the speed change meter and the gravity from the gyro and all that, and evening it out and leveling everything out, and it's really doing a good job. Now one thing about the way VISUINO is built, it is built on a normalized scale. Now that means that a normal analog on the Arduino is 0 to 255. With VISUINO, it's 0 to 1. Now, 0.5 is the midpoint. And the reason I think that Boeing did this is for the ease of compatibility with all the other elements. If you find a common center point and you can use that common center point, then you are going to have no problem getting everything to match up. Now you see the numbers, how they changed on the scale? That's because after a while, the Kalman filter will actually begin to reduce the distance that it will take it. Like right now, it's sitting at 0 to 1 at 0.5 balancing. And now if I tip it all the way backwards, it goes to 1. And I tip it all the way forwards, it goes to 0. Now that means if I tip it forwards, it's going to give reverse motor. That's why it's going backwards. If I tip it backwards, it's going to drive the wheels forwards. So it will actually reverse the direction that it's going. You can tell it to swap it over or whatever. One other thing that I did do is I cleaned up a bunch of stuff here. Let me get rid of this for a second and show you. Now, the way I got this put together, the accelerometer is maxed out with all of its settings. Nothing is turned down. So all the gyroscope's on 2G, and the accelerometer is also at its max setting. I am still subtracting the value to get the center point. Now, I was taking it from a subtract value to a mapping, but I got rid of the mapping. What I did was I did the math from what it was, and then took off 0.5, and then that gave me the 21606445325, and that's the balance point. The reason I took the 5 off is because that is the balance point, where you want to be. So you find your accelerometer averages, get the subtract value. Now the limit, you want to limit it between 1 and 0. You don't want it going over or under, because your motors will lock up and all kinds of strange stuff will happen. Strange shit goes on. Now after that, it gets an average period of 1,000 milliseconds, or no, that's actually not even milliseconds. That's microseconds. Okay, so 1,000 microseconds. Wow, that's like 1 millisecond. Holy cow, I gotta turn that up. Okay, but speed change meter is still the same, coming off of the gyro X after an average period of another 1,000 micro microseconds, not milliseconds, microseconds. Now remember that, it's different. The Kalman filter, I left all of the numbers as base. What it comes when you just put it up there, and it actually does a good job. Now if your robot does not turn and tip the right way, then you may have to open it up a little bit. Now you see those numbers, how they kind of closed up a little bit? That's because the minimum and maximums haven't been changing. It's auto balancing itself. So if it stays in one position like that, if it stays there for long enough, like at the 0.3, all right, the scale will automatically set itself back to center. The reason for that is for weight. Now for CUTSIE WHUN, he's going to have a couple arms, and he's going to have one arm and then one minigun on the other side. So the one arm is going to have a laser point, and it's going to kind of point at a target, and then the other arm, which is an airsoft minigun, the insides, the mechanics of it, is going to shoot airsoft pellets at a target. So this is kind of an important step here, is to get the balancing correct so it auto corrects itself. That is what you really need, is the auto corrections. Now it's kind of a tricky mathematical thing, but the Kalman filter actually does a really good job of it. Now right now I'm sending these to packets up there for the dials down here, but the motor style that I use. Okay, one thing I want to say before I do this, if you are going to try and build this, and you take your motor shield, your motor board, okay, and you put it up here, and then you're going to take your output from your Kalman filter, and you're going to input it to the forward backwards. Now remember, 0.5 is neutral. So if you're going to 0.6, it's going to back up. If you're going 0.3 or whatever, that direction, it's going to throw it in reverse and straighten it back up. Now, if you have this packet or text in line, it will not work. You must get rid of the packet command right there, or it will block the signals going to the motor drivers, and you won't get nothing, or they'll lock up, and you'll have all kinds of funny shit happen again. So what we're going to do is get rid of the packet. Alright, so now we've just got the motor driver board. There's multiple different motor drivers here. There's a 3-pin bridged, like that. There is a 2-pin direction speed, like this. You have to be careful with these, because you see this one here has 3 outputs: forward, reverse, and speed. Alright, this is a good base. The dual motor driver right here is a very good base one, because you can use analog switches. So if it hits forward, you take this to an analog switch. Let's go switch. Let's find out. Analog on off switch. Alright, let me find it. Come here, you. Alright, so we've got this analog on off switch here. This motor driver, or any of them with a digital signal, for the forward reverse, you would simply put 2 of them there, like so, like this. Now one would be for forward and one would be for reverse. So you would need 4 analog switches, 2 for each motor, forward, reverse, and then the speed just goes to in and then out. Okay, that's all. That's the most common basic one. Now the one that is in CUTSIE WHUN is a dual PWM without a trigger pin. There's no activation pin on it at all. So hold on, let me get rid of this one. So basically this one just takes, it has 2 pins for each motor coming in, AB, forward, reverse. Okay, now coming from the Kalman filter, it goes right into there, and you're going to think, well, it's only got 1 wire coming in. And that's all you need, because you're actually looking at the programming. You're not looking at the hardware. Okay, so the Kalman filter is feeding it a 0.5 as neutral, right? So if you take your forward and reverse pins and put them on your analog, so I've got my motor driver board inside CUTSIE WHUN wired to pins 5 and 6 and 9 and 10. So 9 and 10. And that is literally all you have to do to get something, you know. Whoops, what's that? Oh, yeah, well, yeah. Okay, so anyway, so now we got the dual motor driver board here. Some of them have adjustments down here on the sides. Initial values. All right, now if you're having problems with your motors, if you're bleeding off to one side, let's say you're going straight and it keeps cutting left or cutting right, you're going to want to bump these initial values here up or down, you know, 0.0001000 or something like that. You know, a very, very, very low figure to see if you can get your motors spinning. This is your motor speed adjustment to get them timed correctly. Now later on we are going to add some sensors to his motors so he'll be able to tell how many RPMs it's doing. But basically this is it. That is the only thing that it's using right now. 2 wires off the 6050. We've got a subtract value right there to get the center point, balance point. Remember, get your number and then subtract 0.5 from it and enter that value into, see, the number I got was 0.71606, and this one I set it at 0.21606, so I took off 0.5. You're going to want to limit it. You have to limit it between 1 and 0. You'll get errors. Always use an average period to get rid of noise. That is a big thing. Even if it's just 1,000 nanoseconds, it does help, because you're talking, probably 50 cycles of the gyro during that 1,000 nanoseconds. So instead of catching one number, you're catching 50 with an average out of those 50 during those 1,000 nanoseconds, which is 1 millisecond or some crap like that, or 10 milliseconds, or I don't even know. My head hurts. Too many numbers. But this is basically how it's done. Let me save this and then upload it. Now, for uploading, if your motors are going backwards, simply switch your wires over. You know, the blah z blah thing. That's all you got to do. So let's go ahead and do this, get it uploaded. And I did switch over to a Nano. I am going to be moving to a Maple Mini shortly, as soon as the support gets going back for it, because of the communications that it can handle with the RC controller. The Nano can do it, but the Maple Mini is like 10 times as fast, and it can just rip right through the readings. Alright, so let's see what happens here. Turn it on. Yeah, it's working. It's working. See, hear it? Hear it? So that's forward. Yeah, it's working. I got one of them backwards. One's spinning the wrong way. I gotta take care of that. Okay, so basically that's it. That is how it is put together. Remember, motor drivers are at 0.5 for neutral, 0 to 1, 0 to 1 on all of the motor driver boards. Now, you can also do this without a motor driver board, and I will make that video next on how to do that. In case you don't want to put it through this, you can send it through the transmission steering, which gives you direction and speed. So, thank you for watching again, and I will have another one soon.